So, section 3.9, energy and chemical and physical changes. And here's where we start to look at how energy affects the behavior of matter. General principle is that systems with a high potential energy are going to tend to change in a way to lower their potential energy. So if we can remember that by thinking about a ball on a hill, maybe like a heavy ball like a bowling ball or something. If you have a bowling ball sitting on the side of a hill, is it going to just sit there? It wants to roll to the bottom of the hill, right? It might get enough kinetic energy and momentum that it goes down the bottom of the hill and starts to roll up the other side, but eventually it's going to end up at the bottom of the hill. Things in nature tend to go for lowest potential energy. This works with teenage boys too. I had two. Now one's turned 20, so he's not a teenager anymore, but he still acts like one. So they tend to go to this lowest potential energy state, which is flat out horizontal in their bed. I mean, they just sleep a lot. Where's Zach? Oh, he's sleeping. Okay. So they get up and they go to football practice or whatever, and they go out and they do these things, and then they come home and they return to their ground state, their resting state, and maybe they're like, texting or something, but they're horizontal, they're flat. Okay, so everything tends to go to this lowest resting state. That's natural. So anything with a high potential energy tends to be unstable. Like my pen here, when I lift it up, it's got higher potential energy, it tends to be unstable. If I let go of it, it falls into the sink. That's lovely. I'll have to watch that later. Think of the cartoons where, they've got this piano hanging out the window, right? That's an unstable situation, right? That rope breaks and it's going to land right on Bugs Bunny's head. So that's kind of a picture of the energy driving matter's changes. It can drive physical changes, it can drive chemical changes. Some substances have a great deal of potential energy. TNT is one of them. Okay, trinitrotoluene, that's a mouthful, is dynamite. Okay, it's explosive. You give it a little spark and it releases tremendous amounts of energy. Where did the energy come from? It was stored inside the molecules, so that's a potential energy. So when we look at chemical and physical changes, we have two words that describe what's going on with the energy. And these are exothermic and endothermic. And it's important to get these words straight in your head. So here we have exothermic and endothermic. And again, understanding prefixes can help us out here. In an exothermic reaction, we have an illustration of it here. The reactants, what we start out with, starts at a higher energy level. Here in this drawing, as we go up, the energy level is greater, which is a little bit like raising the pen above the table. The higher you raise it, the more potential energy it has. So the reactants, what you start with, have more energy than what you have as the products. The products are lower in energy. That means that energy had to be given off or released. Energy exits the system in an exothermic process. Okay, so exo has to do with exit, right? Exo equals exit. And what we do when we think about these things is we have to define a system and the surroundings. And so it's always in terms of the reaction or the particular thing we're looking at. Is the energy leaving it or is it coming in? If it's leaving, exit, exothermic. Endo is a little bit like the word in. Endo equals in. So an endothermic reaction, energy is coming into the reaction. So looking at the illustration here, again, we're graphing energy going up. Now the products have a higher energy than the reactants. The reactants had a low energy to start with. They absorbed some energy and got to this high energy state. So maybe this is James and he drank a Monster energy drink. and now he's up here and he's got all this energy. He's actually quite entertaining when he's got a lot of energy like that. You know, you get up there and you're all full of energy, higher energy, endothermic, because energy came into you. Okay? Is that a stable situation? No, it's going to wear off and he'll go back to bed eventually. So let's do an example here, looking at some situations and identifying, are these exothermic or endothermic? So wood burning in a fire. So we're thinking of the wood itself. Is it taking energy in or is it giving energy off? It's giving energy off. Energy is coming out. That's why we burn wood, is to get heat, because it gives off a lot of heat, right? So if the energy is leaving, this is exothermic. How about ice melting? So what causes ice to melt? It has to get warmer, right? If the ice warms up, increases in temperature, how does it do that? Does it do that by giving off heat or by taking in heat? By taking it in. So ice melting is an endothermic process. Okay, what about the opposite of water freezing into ice? It must be exo. I mean, we just discussed its opposite. If one state change is endothermic, the opposite state change must be exothermic. Your freezer has a condenser and a compressor and a fan, and what it does is it is removing energy from the inside of the freezer, and that's how it makes it colder inside. So you put water in there, and the freezer is taking energy out of the water. It's an exothermic process. Sometimes we have in our minds that exothermic processes generate heat, and that's not true. Processes that generate heat are exothermic, but not all exothermic processes generate what we would recognize as heat. Water freezing is actually giving off heat, but it's not obvious to us. How about natural gas burning? Exothermic or endothermic? Exothermic. That's a lot easier to recognize, like the wood. And when we light the burners in here, that's natural gas that's coming out, and we're lighting it on fire, and it generates heat. And if it keeps up being so cold in here, we might have to do that during lecture. Any questions about this example? You have to think about, okay, what piece are they talking about? The ice melting. Okay, what's happening with the ice? If you're holding ice in your hand, it feels cold, right? It feels cold because there's energy going from your hand into the ice. In terms of your hand, that's an exothermic process. In terms of the ice, it's endothermic because the energy is going into the ice. So it's a matter of perspective, really, like money changing hands. Okay, so I'm paying somebody to do something. Well, they're getting the money, I'm giving the money. Energy isn't created or destroyed, just like money pretty much isn't created or destroyed. It has to come from somewhere. So if it's coming in to me, then it has to be going out from someone else.